This is an introduction to finding derivatives of exponential functions. As you see here, we have two main formulas that we're going to be using when we see that we need to derivate an exponential function. The first one is when the base is e. E, remember, is an irrational number, is the number Euler, and it's a very common base for exponentials. An example of this kind of function would be e power 2x. The other type of functions, exponential functions, are the ones that the base it's an actual number, any constant. 5, 7, 10, 20, 100, any number, and the power, it's the actual polynomial or function that includes the x. An example of this type of exponential functions would be 5 power 7x plus 3. So the x, the variable, is in the exponent. Check out that in these functions, the exponential functions, the variable, it's in the exponent. That's why we know these are exponential functions, because the variable, it's in the exponent. So to help you with this little web assignment, this little homework, I'm gonna solve a few examples that come from that homework. So this is the problem number 2 and 5 that you're gonna see in your homeworks, just with another, probably a little change in the numbers. Let's start with the pink one, the one on the left. So because that one is base e, we're gonna be following this formula right here. With exponentials, we always have in the answer the same exponential. Check out, in the initial functions we have e power u. And in the derivative, we also have e power u. So the first step here is writing for the y derivative, the exponential exactly the same. This is always going to happen with exponentials. And then we add the derivative of u, so the derivative of the exponent. In this case, the exponent is, this one it's u, x plus 6, therefore the derivative of x plus 6, it's 1. So that one would be multiplying the original exponential function. And that's it. We have covered the whole derivative for that exponential function. Remember that the plus 7, it's a different monomial. It's separated because of the plus. So in this case, we would apply the derivative for a constant that we know the derivative of 7 should be 0. The last thing I will do is just rewrite this function without the 0 and the 1. The actual answer for this function is x plus e exponential x plus 6. Then we have the second formula, the one on the right, that it's for exponential functions when the base it's a constant that is not e. A number, 6 in this case, or it can be again 10, 20, 12, whichever number. The first step is gonna work the same way. We have a power u, that in this case is 6 power x, and in the answer we always have the exponential exactly the same. So the first thing I recommend you when you see an exponential function is writing exactly the same as you have at the beginning. The second part, it's also the same. We need to multiply times u derivative, so the derivative of the exponent. In this case, the exponent is u, that it's x, so the derivative of x should be 1. So that 1 is going to be multiplying 6 power x. The only difference between a formula derivative with a base e and a base constant is this section right here, the natural logarithm of a, which in this case, what it's a? The base of the exponential. So the only difference between these two is really when the base is not e, when the base it's a constant, we need to add the natural logarithm of the base, that in this case it's 6. The last step that we would do is just write it in order. First, we would have any algebraic functions, numbers, constants, or letters. In this case, we don't have any. The next one is natural logarithms. So we have that one, natural logarithm of 6. Then, and in the right side, we would have like any exponentials, in this case 6 power x. So that would be the answer of this derivative from this exercise. Let's do another two just to clarify and to be sure we know how to derivate exponential functions with a little bit more complex examples. The first one, the one on the left, is very easy. But the reason that I'm giving you this one is because let's see what happened. Because in this case, the exponent, it's only 7. It doesn't have an x. It doesn't have a variable. So what's going to happen there? Let's see. In this case, the derivative, because it's an exponential function, we always write first the exponential function exactly the same. And after this, because we're in the formula of base Euler, we need to multiply times the derivative of the exponent only. So if the exponent is 7, if this one is u, what is the derivative of 7 alone? 0. Therefore, 0 is going to be multiplying our exponential function, and the answer is going to be 0. This happens because we actually do not have a variable in the exponent. It's only 7. So that's the reason it becomes 0, because the exponent is not a function. It's only a function. The one in the right is already solved to save a little bit of time. But what I want you to see is that exponential functions can also be combined with product rule or quotient. In this case, we have a product rule. Why a product rule? The function in the right side is exponential. That is multiplying every other variable with the two terms in the variable. So that's why exponential here is the exponent. But we also have the section that is having cannot write sections of this multiplication. Cannot write something x, right? That is not the exponent. So because we have this combination of functions and they are both multiplying each other, we must apply product rule. You know how product rule works. You just have to select the u and the v, find the derivatives of those, and substitute in our product rule. You have here the substitution, then we put that derivative in order. Check out first x algebraic, then we have logarithmics, and then we have exponentials. This is the order we're going to follow every single time. And if in the final answer we have common factors, we should factorize those common factors. In this case, the common factor is 6 power x, and it's the common factor that I'm writing outside. It's the only factor these two monomials have in common. So that is the answer. You can check it out slowly. Try to solve this product rule, that is the number 6 in your WebAssign. And I hope it's a little bit more clear, this introduction on how to find derivatives for exponential functions. So good luck and try the other exercise. Let's see if you can solve it, and we'll check questions tomorrow. Have a beautiful day, everyone.